Hi all, I am Dinto and I would like to show a simple demonstration of my 3D staad model generator application. So let's get started. I will open my app. So it's a simple UI and you have to enter these inputs for a quick and fast 3D model. So I will start with my width as 40 meter. My height will be, I consider now as 8 meter. My near side slope as 0.1 and far side as 0.1. Ridge, I will construct a distance of 20 meter. Sidewall spacing, I will currently give some random spacing. The good thing about this app is that you can give any different spacing, and based on your spacing it will calculate your tributaries and it will apply the loads. Then we'll go to end wall spacing. So for now I'll consider my end wall spacing as 4 at 10 meters. Then we'll go to our near side rafter breaks. So practically what we are doing here is we are telling the application how we want to break our rafters on the near side. So since I have my ridge at a 20 meter, so my both rafters at the left and right will have a length of 20 meter. So I'm breaking it at 3 meter pieces. So I'll do 5 at 3 and balance. Same for far side. Then I'll go with interior columns and I'll consider interior column at a spacing of 20 meter. Then I will consider my braced base at the second bay and the seventh bay. So now the dimension has come done, we'll go to our support conditions. For now, consider all my supports as pinned. Then we'll enter our loadings. So I'll consider my dead load as negative 0.15, live load as negative 0.6, and my collector load as negative, let's say, 0.25. And I'll give my wind pressure. So you will need to calculate your wind pressure and you'll have to input it. Then comes the seismic data. So for now I'll give my SS as 0.6, S1 as 0.19, time period as 12, importance as let's say 1, and my response factors along X and Y as 3 and 4, and my site class as 3. And for seismic code you have 4 options, and I'm selecting IBC22, methodology as LRFT, and the design code for right now I'll set as 2005 or let's say 2010, and then the enclosure condition I'll keep it as enclosed for now. So now that the input data is everything done, let's generate our stat file. So our stat file is generated. Let's open it up and see if it's exactly as we have given. So now that our stat model is open, let's check with our inputs. So let's start with our sidewall spacing. So I'm getting my sidewall spacing as 8, 9, 8, 7, 6, 9, 8, 8. Let's check it with our input. So 8, 9, 8, 7, 6, 9 and 8, 8. So it's a perfect match. And we have given our 8 wall column spacing as at 10 meter 4 numbers. So this is also matching with our 8 wall spacing. Now our height we have given 8 meter and that's also matching. Let's see how our rafters are both broken. It's taking 3 meter, 3 meter, 3 meter, 3 meter and 3 meter plus balance. So that's also a perfect match. Let's see our interior column spacing, which is at 20 meter spacing, and then our based base at second bay and at the seventh bay. Now let's check our support conditions. Since we have given everything as pinned, our model is also all the supports are pinned. Now let's go to loading data. So first we'll start with our seismic. We'll go to our definitions. So we had given our IBC code as IBC 2012 and same it has taken. Then for our parameters we had given 0.6.19, 12, 1, 3, 4 and 3. So that's also is matching. Let's check for the seismic weights. So this is the dead load of the structure. Let's see it with the dead loads that we have generated, and that's also an exact match. And the second is for the collateral loads. So let's check that one also. So our collateral load is also matching. And then based on seismic weight, it has generated seismic load cases in all 4 directions. Then we'll check out dead loads. So it has generated dead loads separately for all the different tributaries that we are getting for the structure. So no need for anything else to do from our part. Similarly, in date live collateral, everything is generated. Now let's go to our wind load. And the good thing about our wind load is all you have to give is your wind pressure and then your building enclosure condition. It will automatically calculate the wind coefficients and will generate it for you automatically in the 3D model. And it will generate all the 8 cases. Now we'll go to temperature. I have considered temperatures 25, positive and negative. You can always update it based on your requirements. Perform analysis generated. Let's check the design parameters. So our design code 2010 is fine. Method we have chosen is LRFT, that's also fine. And for the build-ups, it is taking the necessary parameters. Then for the columns, our height was 8 meter, so it is taking LZ as 8 meter, KZ as 1.2, but the KZ should be 2, which is a small bug. I will update you on that. And then for the rafters, it is taking us 20.1. Let's check the length. Yeah, it's exactly a match, 20.1. Similarly for the far side columns, it is taking exactly. And you can always customize your L by UNT and UNB based on your specific requirements. And then for the wind columns, we are getting height as 9, 10, 9, and the exact height is matched in our parameters. And then finally, we check out for the build-ups and steel and take off for build-ups, and for the bracings are generated separately. So basically our stat model is ready. Now all we need to add is our load combinations. So for load combinations, we can use the automatic load combination generator which is available in stat. So let's say we'll take some code, and then I will just generate my strength cases. So now my strength load combinations are generated. Now let's add the same to our load list. We'll go to our editor, scroll down, find the load list location. This is also generated. Just you have to input our load list numbers. And if you want define envelope for the separately for strength and subject, that also you can generate it, which will be automatically generated in the number. Just you have to enter your load cases for the same. So now our stat model is completely ready. Let's give it a run and check how this goes. So our model has run without any errors. We are getting a few warnings. The warnings are because since we have given only the minimum sections to all members, it's not passing in every case, so it's failing. So once you optimize it, you will be free from all those warnings also. So that's it. So now your 3D model is generated in a fraction of seconds. The video has gone longer than I had expected, but I will make a part 2 of this series to demonstrate how the application can be used for unsymmetrical geometry and also multi-cable frames. If you find this video interesting and would like to get instant updates on my future videos, then do subscribe to the channel, and thanks for watching.